Hi, this is Gilbert Standen, Principal Solution Architect of the Orabuntu-LXC project. You can find the Orabuntu-LXC project at GitHub. Here's the main page, github.com, gstanden, Orabuntu-LXC. Today I'm doing a brief video to show how you use the scst-files.tar bundle, which comes with the Orabuntu-LXC software project, to install DKMS-enabled SCST packages, Debian packages, on an Ubuntu 16.04 server using the HWE kernel. So let's get right into it. When you unpack the Orabuntu-LXC distribution, there's an scst-files.tar that's in the directory Downloads Orabuntu-LXC Master Orabuntu Archives. Let's take a look at that. And as you see, here's the scst-files.tar. You need to unpack that. If you've done the full Orabuntu-LXC install, it's already been unpacked for you, and so you just cd to the scst-files directory. Now, to install the SCST Linux SAN using the scst-files.tar bundle, after you've unpacked it, you simply run /create scst.sh, and that's going to run this file here. And that's all there is to installing Debian-based DKMS-enabled SCST packages on Ubuntu 16.04 server. So now we're going to go through the install. It's fully automated. It goes pretty quickly. It takes a few minutes, but I'm going through this particular flavor of the install because, as you can see, the HWE DKMS on 16.04, there's a problem with DKMS packaging in some of the kernels. At least that's what I have found. So the workaround that I've found is that you go ahead and install the HWE kernel in 16.04, which is a supported option, and this upgrades your kernel and allows you to then use the scst-files.tar to build the SCST DKMS enabled Debian packages. So I'm just watching the install go on, and when there's anything relevant, I'll make a comment. Okay, so this is the branching in the create SCST install script where it advises you that there are issues with the 440-87, 88, and 89 series of Ubuntu kernels. And what it recommends, giving you some background that you can check separately, independently, is that you go ahead and answer Y here to upgrade to the 16.04.3 HWE. It stands for Hardware Enablement Kernel, which upgrades you from 440 to the 410.0.30 generic kernel. And this kernel, this entire process, you can see here if you go to this wiki and read it. This is a fully supported functionality that Ubuntu Canonical Software provides, an option that you can use. So we're going to go ahead and take that option, and that's going to cause the kernel to be installed as we answer these prompts. I left the prompts in for this particular operation because you're making a decision to upgrade your kernel, so I think it should be interactive. This could be easily scripted to just echo the Y into the command so that you could make this fully automatic. If you wanted to use this to deploy SCST Linux SAN unattended on a large number of servers, you could do this way. But right now we're just doing it interactive. So we had to answer Y to the option, the branch in the create SCST install script, and then we had to go ahead and answer Y. And if you hear my cat in the background, I'm sorry, there's a cat in the background. He's a little bit unhappy today. I'm not going to re-record the video just because he's here, so sorry about that. Alan's making his debut in YouTube. Alan the cat. He's been meowing a lot today. Okay, so it's completed the update and now it's going to reboot. So be aware that there's a reboot involved. It has to reboot to load the new HWE kernel. So I've actually lost my connection here. If I guess I'll have to open up a new terminal. So let's open a new terminal. Okay. So you can see we've just been up for 0 minutes. So now we're back up. And now we have to go to that same directory. Now, let's do a uname -a. And you see that we were on 440. Now we're on the 410.0.42 generic. So now you just run create scsT.sh again. Just run the same script again. This time, when it goes through, it's going to find that the HWE kernel is present, and it's just going to continue on. And fully automated, it's going to build the Debian DKMS enabled packages for SCST. It's going to install them. You can see the note here about HWE DKMS for Xenial. So we have to pull some code. We have to pull the SCST code down from SVN, SCST SVN. So that's why it does a ping test to SVN. So now we're installing some packages that are required for various things. Some of the packages are that are going to be installed are just required for SCST, and some of the packages that are installed are required for building DKMS Debian packages. So I believe this set is the just the packages required for SCST. So now that flew by pretty quickly, but this is actually the section that's installing packages required for DKMS. And this is a good chance to practice my Christopher Walken imitation since there's nothing else going on. So now, a little bit of humor there, sorry. Now it's pulling down the SCST source code from SVN. This is the latest revision, 7334. And now it's going through all of the DKMS build steps. And the advantage of using DKMS, by the way, in case you may not know this, is that with DKMS on Ubuntu, when you upgrade your kernel, you won't have to rebuild your SCST binaries after the kernel upgrade. DKMS takes care of all of that for you automatically, so you don't need to do anything for that. That's why DKMS is so great, because it takes care of everything for you transparently across kernel updates. So now we're at the step where it's building the initial modules for the 4.10.0.42 HWE kernel. And that HWE, you know, there's nothing really special about an HWE kernel. They call it the hardware enablement kernel, but it's really just a 4.10.0.42 kernel. I mean, there's no difference between an HWE kernel and the 4.10.0.42 generic kernel. What it means is that they give it that name, hardware enablement, because by installing it, you often pick up functionality for hardware that was introduced after your distro came out. So, you know, various firmwares and things to operate Wi-Fi equipment, etc. So there's nothing magical about the HWE kernel. It's just an updated kernel that has the side effect of enabling hardware. So they call it the hardware enablement kernel. So this step, this is where I can do my Christopher Walken imitation and tell you that you have to be careful, because it can turn into an Al Pacino really easily. So now the modules have been built. You see it finished. So now it's starting up SCST, and there you see we've got it started. So that's a good sign. It all looks good. It's going to run through some tests eventually to make sure that SCST is running correctly. So now it's going to actually build a SAN. It's going to build a target. It's going to build a target group. It's going to read the initiator. It's going to create the file-backed LUNs. It's going to create devices from those LUNs. It's going to add the LUNs to the initiator, to the target, etc. So now it's displaying the target, the group, and the initiator. You see that all looks normal. Now it's creating the backing files. So these indexes on the file-backed LUNs, like 10, sysd10, those are, when you install with Orabuntu-LXC, if you do the entire Orabuntu-LXC install, it automatically selects that index based on what DHCP address was assigned to your Open vSwitches, so that the Open vSwitches and the LUNs are indexed with the same number. It's just kind of a thing to help you keep track of which LUNs are on which Open vSwitch deployment on which host, because Orabuntu-LXC is a multi-host deployment tool. So the different servers, physical hosts, and VMs and containers, you know, can have different indexes, unique indexes, so that they are differentiated and you don't get confused about which LUN you're looking at on which host. But if you install SCST files standalone, let's say you don't want Orabuntu-LXC, so you just download Orabuntu-LXC, then you unpack it and you take the scst-files.tar, just untar it in the directory that it would have been in if you had installed the whole Orabuntu-LXC, because I'm just telling you, at this point there are still a few hard-coded file paths in some of this software, and it's on the roadmap to get rid of that, but it's better if you just install things from where they would be if you had downloaded the distribution into your downloads directory and then untarred it or unzipped it. So So that again is that downloads Orabuntu-LXC master, Orabuntu archives, and then in the archives you tar-xvf the scst files.tar. So if you do that just in the standalone mode and you run create scst .sh, it will put an index of 1 on the file backed LUNs. So you'll have like sysd1, data1, reco1, and that's in the standalone mode, which it detects automatically. It creates those LUNs with a 1 index. But you can go into the create scst oracle.sh file and you can change that index. So if you don't want to have it be data 1, you can change it to data 4 or data 200 or data 5,762,000, whatever. I mean, up to whatever kind of limits are enforced by the various software, but there are no real restrictions on what you can put. You could even use a non-integer. You could use some sort of a word or a descriptive name. You do have to keep that sysd, reco, and data prefix though, because I believe that the multipath.conf builder uses that. So now let's see if we, so scst files.tar creates 3 different sort of like locations where you can access your LUNs. So in devmapper, of course, then in devasm, and then if you do ls-l/dev LXC LUNs, you get these. Now, what's important to realize is that this dev LXC LUNs exists for a specific reason, and that's because the way Orabuntu-LXC presents storage to Linux containers is it mounts this directory right into the container. And as you may know, in version 5 of Linux, version 5 and 6 of Linux, you had these device nodes, but then in later versions of Linux, the maintainers went to a linked paradigm, which is good. There's a lot of really good reasons why they did that. But the problem is that with containers, if you want to present your storage directly into the containers, now how do you, now you have everything in devmapper, you end up having to present, 2 different things. You have to present the link where the link is located, and you have to present what's in dev, but you can't, because presentation of something to a container is, by directory. I mean, unless you use LXC attach, that LXC device command, which doesn't work for certain types of applications such as Oracle database. The database doesn't like the LUNs when they're presented in some sort of non-standard way. So this option was created in the udev rules that come with scst files.tar, so that you can just present the device node itself. And this device node is actually, I'll show you the etc udev rules, rules.d 99-oracle rules. So the rule that generates this is the container friendly multipath naming. So you see, this is the rule that generates these device nodes, and as you can see, it uses the DM kernel udev switch. So you're getting the multipath devices. So these are fully multipath devices, but they're expressed as device nodes instead of as symlinks, which is what you want for containers. And you can change this to match your container. So suppose you had 20 or 30 different device nodes, LUNs, in this dev directory, and you want to, you can break up these rules, and you can change this right here. The dev LXC, you can change it to like dev container 1, right? And you can have some rules that say dev container 1 and some rules that say dev container 2, and you're keying it to the SCSI ID of the LUN. So you can have multiple directories under dev container 1, dev container 2, and that way you can be presenting the storage just to the container that needs to see that particular storage. So just be aware of that, and that's about it. We can sudo service scst status, and ps-cf grep scst. So there you have it. That is the Ubuntu 16.04 deployment of SCST using DKMS enabled Debian packages, using the scstfiles.tar bundle, which comes with Orabuntu-LXC, and you can find the Orabuntu-LXC project here at https github.com gstandin Orabuntu-LXC. And in case that's hard to read, there it is, https github.com gstandin Orabuntu-LXC. That is where you can get the SCST files .tar bundle, and you can install that with Orabuntu-LXC, or you can just install it standalone. And that's about it. That's about it for this presentation. And I'm Gilbert Standen with my special guest star Christopher Walken. We're signing off from this presentation for today, but stay tuned to the project. Follow the Orabuntu-LXC project, and you'll probably pick up some good code and good tools to build things.